files, right? So a file will be all over the data block. So you need to use the block table to find out where in the data block the bits of the file are, right?
Okay.
So it's literally, it'll say like the first block is 6, and you read the data at position 6, and then you go to the block table at position 6, and it gives you a new number, which will be 10. And then you read the data at position 10, and you go to the block table at position 10, and it gives you a new number, which will be position, 100, right? And you read the data at position 100, and then you go to the block table, and it will give you a certain value that'll be end, for example, and it's done.
So and is this one, right? I think I
Yes,
see.
it is given to you exactly. So it's empty if the file is unused, so that might be like a directory or something.
Yes.
And it will be end when there is nothing else in the file. So once you've reached the end of the file, you can stop reading.
So every time my first block changes, right?
Mm-hmm.
So
Every different file will have a different first block, but it will always stay the same, right?
Like so my third file is gonna be my first block as well.
No, so first block will tell you where the file begins on the data directory. So the first block it'll always be the first block of the file,
Yes.
but it could be anywhere in data. So it could be block 112, it could be block 13, it could be block 47, right? It could be any number.
Oh.
And it will always be wherever that data is written on the disk.
So I am the one who's gonna write down this code to find. No, I'm not gonna write it down.
Yes, you are. You're going to be the one who has to find where the data is.
Oh.
So you tell, because you can only read and write at offsets, right?
Yes.
So you can only say disk read at offset this number of bytes. So you need to tell the disk which offset you want to read, and that will be inside of data at whatever offset first block is, and for the size of whatever it was, 512, right? So you read that block, you read that data, and then you use the block table to find out if there's another piece of data, and if there is, what offset inside of data that block is at, right? So essentially, you're using the block table to build this list, right? Yeah. So a file might be at positions 1, 5, 6, and 7 or something, right?
But you told me that block table was already written, like okay.
Yes, the block table will be written when you've created a test image, but if you write a file, or if you delete a file, you need to update the block table. Because if you write a new file, you're going to have to find empty blocks to put the data, right? And you need to record in the block table where that data is.
Okay, so I understand that.
Yeah. So like, if you go to the third page on this thing, so you can think of the block table, right, as being this big long array, right, and it's filled with numbers. So it might be the number 3, and then 7, and then 42 and 112 and 56, and then let's go back down to 5 and then 10, right?
Okay.
So there's loads of numbers, right?
Yep.
In fact, I tell you what, let's change 56, let's change that for end. So that special value called end, right?
Yeah, 00F, I guess.
Yeah, whatever it was, FFFE or something.
Yes, FFFE 0.
So let's say your README file starts at block 42, and actually these are really bad numbers I've picked. Hold on, let me restart, because this isn't going to make any sense. Let's say we've got 2, 4, 1. We'll just do everything up to like 10, I think. 9, 7, 10. So let's see, 1, 2. What were we missing? 3, 4, 5, 6, 7, 8, 9, and 10. Okay. And then what we'll do is we will change one of these, I think, randomly for end. Okay?
Okay.
So let's say that so this is position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so at the top we've got our indexes, and inside the array we've got these numbers. So end is at position 5, 5's position... God damn it, I've immediately done something very stupid. So that will have to be 9, let's say. 3 is here. So let's say that first block points at 10, right?
You mean
So
8?
let's say we've got
You mean 8
the
or
file
10?
name to readme, the first block equals to 10, and the size is equal to, I don't know, some random number, it doesn't matter.
Okay.
Okay, so we know that the first block is at 10, which is here. So we go to the data, right?
Yeah.
So if this is data, and let's say it's split up into all these different blocks, and there's, I don't know, 10 of them, let's say.
No problem, I
Probably
understand.
not going to divide this into 10, but let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a bunch of other stuff, doesn't matter, right?
Okay.
So you have first block is equal to 10. So you go to position 10, which is here,
Yeah.
and you read that piece of data into some buffer. So you read that. Then you want to find out where the next part of the file is, right? So you go to the block table, which is this array at the top, and you read at position 10, and it tells you to go to position 8, right?
Yes.
So position 8 is here, so the next block is at position 8. So you read here, so you've read 10, and then 8. Where do you go next? Well, when you read 8, it gives you the number 3, so you go here, right? So you now read position 3, which is there, and you want to know where to go next, and it says go up to 9. 9 tells you to go over here, right?
5.
So you read position 9,
9. You
put
got
that
9.
in, and then this tells you to go to position 5, which is here. So you read position 5,
Yes.
and then the next value is end, so there's nowhere else to go. And so you know that readme, if you read 108395, that
Yes.
will give you the whole file, right? Does that make sense?
Yeah, now it makes sense.
So the block table is just telling you where to go, and the data table is the data that you need to read.
Okay. Which part I'm gonna write it down? The code part? I think I'm gonna write it down in
All of it.
what the.
So you need to write all of it, right? So when you do read directory or read file,
Yes.
you'll need to write the code that jumps around using the block table and reads data from data using disk read. And you'll need to calculate what those offsets are using the data from block table.
So what is your recommendation for me? Like where to start until Wednesday for TA session?
Yeah, that's a tough one. Starting this is like the hardest bit. I would say start with the functions, get attribute and read directory, and only look at the root directory initially. So don't try and do it for other directories, because other directories are saved on the disk. So that's a bit more complicated. But basically, get attribute will require you to find an entry on disk,
Yes.
and read directory will also require you to find an entry on disk. So maybe start with read to directory, I think is probably the easiest. So it should be the second function in that file at the very top.
Get attribute.
So there's get attribute and there's read directory just below it. Yeah, here. I would probably start with read directory, and basically what you're going to do is you're going to use that variable called filler, and there's an explanation just above, and you're going to use filler to write file names into that buffer. Right?
Yeah, give me a second.
Yep.
Write buffer names.
Yep, file names into the buffer. So basically you give it a name, a file name that you've got from an SFS entry,
Yes.
and you pass it into filler, and you use it just like it's written there, so filler buff name null 0, right?
Yes.
Just on the left. You just use it like that, and you write all the names in a directory into the buffer. And that's all you have to do, right? You have to return the correct value 0, I think, on when you've done it successfully. So what you want to do, where you want to start, is just reading the root directory. So you want to write some code, just use print statements and whatever, just write some code that reads everything that's in the root directory.
I'm gonna write it down in here, right?
Yep. So all you want is to put some code in there that uses a bunch of print statements, that looks at the root directory and prints out every file name that's in it. And then when you've got this function working, when you've understood that, you can start writing those file names to the buffer using the filler function.
I can start with what?
Start with the root directory.
So then I can start with this one, get attribute.
Yeah, you can also do get attribute. So redirectory, you can also expand it to work with subdirectories. But once you've understood how to do the root directory, that should be easier. And get attribute will basically, when you've given it a bunch of file names, so when you try and list a directory,
Yes.
the operating system will call read directory on it. You'll say that it contains readme and foo.
Yeah.
And then the operating system will try and get attributes on readme and foo. And you'll have to say it's a directory, it's a folder, it's a file, whatever, right?
Okay.
So the get attribute function is relatively short, but you'll need to find entries first.
And
So
this-
you need to read through the disk and find where these entries are. And so you have to read that SFS entry and say it's a directory or it's a file or whatever, and what size it is, etc.
How do you understand it's file or directory?
So there is a variable, if you go into sfs.h and scroll down, you'll see size mask and directory. So for an SFS entry, the size variable contains how big it is and also whether or not it's a directory. So the lower however many bits are the size, and the top 4 bits are whether or not it's a directory. And so you just need to read the size, you logical AND it with the size mask, and that will tell you how big it is. And if you logical AND it with the directory, that'll give you 0 or 1, and it will tell you whether it's a directory or not.
I don't understand. What's
So you literally just have to say, like, if you have an SFS entry's size, you do size and size mask, and it will tell you how big it is. It will just give you a number like 100 or 200 or whatever.
what do you mean size of? You mean size of?
No, it's size mask. So the variable here that you were looking at,
Yes.
right here, is called size mask.
Okay. Yes.
So if you take the size of an SFS entry and you
Si-
AND it, you use logical AND. No. It's got a variable. If you scroll down to the bottom, you see how it's got a size variable. So you take that size variable,
Yes.
you logically AND it with the SFS size mask, and it will tell you how big the file is. And if you take that size variable and logically AND it with the SFS directory mask,
Yes.
it will tell you whether or not it's a directory.
Okay. Yeah.
Yeah?
Yep. Understand right now.
Okay. Is
Yeah, it's helpful.
that
Yeah.
enough at
Yeah.
the moment, or
Yeah. Thank you.
are you still a bit lost?
If someone doesn't answer me the question, I'm okay with this information.
No one's answered it right now, but I'm going to
No
I'm
problem.
going to send them a message and I can email it to you.
Okay. Yep.
So I will take your name.
Do you want my name?
Yeah, I'll just write it down so I can remember who I'm. So I know how to email it to you.
Yeah, no problem. My school number.
Perfect. Yeah, that's good.
This is.
Yeah, just your name should be fine. I've got that here, so I can just send you an email on Canvas or VNet or something.
I will be appreciated. Thank you very much for listening.
Yeah, don't worry about it. So you understand what we've gone over so far? Then that's
Yes,
okay with you.
That's more than I expected. I'm appreciated.
Okay, good,
Yeah.
good. No, that's absolutely fine. Like that is literally what we're here for, and it's not like anyone else is waiting in the queue right now. So
Yeah, thank you.
it's pretty easy to go over it. So yeah, start with that read directory.
Yes.
Try and just find out what's in the root, print stuff off, and then hopefully you'll have a better understanding at that point.
Okay. Yep.
Yeah.
Thanks.
Okay, no problem.
Yep.
Good luck with it.
Yeah. Thank you.
And yeah, don't be afraid to ask us more questions and stuff if you get stuck. All right.
Yep. Thanks.
Cool.
Thanks a lot.
Have a good day then. See you later.
Bye bye.
Bye.